So yes, I'm Ian Southwood from Energised Work. We've been working, we are a relative newcomer to this sector. We've been doing some fascinating projects around the energy sector in particular. For about the last 4 years, we've done projects in connected home and smart home, in digitising services behind SMETS2, smart meters, and also most recently in looking at new value propositions and taking those value propositions to market that are based on solar and battery technology and some of the services, demand-side response, for example, that come out of that. So we've got an interesting perspective, we believe. So what our goals are this afternoon is to sort of share 4 years' worth of observations. Particularly, we want to talk about some of the challenges that we've seen in the energy sector, and our experience is just the energy sector. It's not right across utilities. But we'll sort of talk about some of the challenges that we've seen and some of our observations, but share with you some pragmatic advice. We hope it will be pragmatic advice, things that you could actually implement tomorrow, particularly when you're trying to bring new products and services to market very quickly, and you're trying to digitize services to support those products. We mentioned that we're a newcomer. You're probably all thinking, who on earth are Energised Work? Despite the name, we're actually not industry specialists. What we are experts in is helping organisations understand the potential business impact of new technology, and then very quickly taking those new products and services to market based on that technology, but always validating as you go, making sure that you're building the right thing, and staying very focused on business outcomes. If you want to know more, please come to the stand or check us out on the website. So this is a hugely changing market. It's quite funny that the energy industry has changed very little in 100 years, and all of a sudden there's profound change taking place. We're heading very quickly towards a low-carbon future. Smart homes and smart buildings are on the increase. Electric vehicles have massively increased over the last 5 years or so. And so when we're talking to senior executives in energy companies, they're aware that this is a fundamental shift is required. And they're asking us questions like, what impact does this have on our business model? What is our new business model? How do we become a technology company, or at least get better at technology? And how do we get better and quicker in innovation? And how to become more nimble? So I'm hoping that for the rest of this talk, Trevor is going to help address exactly some of those questions. So Trevor, shall I hand over to you?
Thanks, Ian. Good afternoon, ladies and gentlemen. I'd like to start off by actually giving you an example, not from the utilities environment, but actually from the agricultural environment. It gives us one major advantage. We avoid breaches of confidentiality with many of our clients. Now, in actual fact, this is a brilliant little example focused on business services and the delivery of business service with a number of supporting digital services, which is really what we do with our utility clients. Now, this is actually stormwater runoff. It's a big problem in many cities, especially when they are subject to flash flooding from big storms. And normally what happens is that the infrastructure, particularly in the sewage disposal environment, gets absolutely swamped by floods. And as a result, the overflow gets mixed with raw sewage, and it literally just overflows into rivers and lakes and even the sea. And many cities have actually become quite innovative about this, and in fact they've offered what is effectively a stormwater retention credit scheme. Now, I'd like to then highlight a very good solution to the stormwater retention problem, which is in fact the building and implementation of urban gardens and green roofs. Now, this is a brilliant solution in as much that the urban gardens help to absorb the storm water, but they also channel that water into big tanks. And those big tanks there actually store the water that is subsequently used for irrigation. So it's actually a very good way of staging and using that storm water. And the other advantage is that, in fact, it's aesthetically pleasing. It actually assists with the greening of cities, particularly with new modern architectures. Now, in this environment, there are actually three major control factors. The types of plants that are used, the actual landscaping of the urban gardens, particularly for new big buildings, and then the channeling of the excess water into those stormwater tanks. And then the third controllable variable is actually the size of the tanks, that you've got the capacity for storing that water. The big problem is there is one massive uncontrollable, which is the weather. How do you actually predict the impact of storms on your urban garden? And in fact, that's where the gardeners have actually turned quite massively towards technological solutions. And in essence, what they're doing is they're implementing a sense and control network that really controls the garden and how it actually uses the network, particularly, how it uses the water, particularly leading up to a stormwater event. In other words, it controls the moisture content of the garden before the storm, and then actually captures all the details about what precipitation takes place and how it actually gets stored, and it derives the information, the evidence that's required to apply to the city authorities for credits to be given back to them, which they use then for justifying and maintaining the urban garden. Now, in essence, what happens is that they install a lot of sensor nodes, and those sensor nodes capture all the information that's required. And in fact, they have control nodes as well for controlling the hydration systems. And all of this data is captured, and it can go either to a local environment or it can go to a central environment, in other words, a cloud environment. And that information is then used very effectively for managing the whole urban garden and maximizing the amount of stormwater runoff that is retained and doesn't go into the sewage system. It also requires very sophisticated software, and that software is sometimes verging on, if not is, artificial intelligence. In other words, got its self-learning capability built in as well. And this, in fact, is a very good example or analogy for exactly what we do with utility environments as well. So it's predicated by the sense and control networks that are put in place, and then the software that is loaded on top of that to actually control everything. Now, I'm sure many of you would have noticed those similarities before, but I would like to actually take this example a little bit further and to show how it is broken down into a number of system components. And it's these system components that are actually extraordinarily useful for matching up with the service value proposition that are going to be provided by the products and services in any business, particularly the utility business. Now, this structure actually comes from a person called Jerry Shen, and the attribution is at the bottom there. The new moats, why systems of intelligence are the next defensible business model. And in fact, it's this structure that helps us to make sure that the systems environment are absolutely in line with the service value proposition of the business products and services, especially from a digital perspective. So taking this example a little bit further, you can see that we have systems of record. Now, these are the basic administrative systems within any environment. And in this particular example, they are the systems that capture the sensor data and manage that sensor data. Also the configuration about the actual site itself. Interestingly, there's a third-party system of record here which is really important. And that's actually the weather forecasting. That actually comes in at this level. Now, all that information is taken, and at the systems of intelligence level, it's manipulated to produce management information for the gardeners so that they can actually take intelligent decisions on about how to manage the health of the plants in the garden. So you don't want them to die, of course. But at the same time, you also don't want to overhydrate them so that you can't actually capture that storm water. So it's a very delicate balance that they're managing here. So they have a system of intelligence that also helps to manage and minimize the storm water runoff. Many of those systems there, and particularly managing the stormwater runoff, actually is artificial intelligence. And then finally, you've got the systems of engagement. And these are the systems that present the data to the gardeners, whether it be on their desktops or whether it's on their mobile devices. It also allows them to take automatic control. I beg your pardon, it allows the system to take automatic control of managing the garden or to be overridden so that the gardeners can take control, and they, particularly when there is an alert or warning, and it needs specific management which is beyond the capability of artificial intelligence. Now, I hope you'll find that is actually an interesting analogy for what we actually do within the utility environment. The benefits for services in general are that it actually enables us to provide a collaboration environment discussing the systems capabilities that are required to deliver on business products and services, because sometimes those capabilities are out of kilter with expectations. It also helps us to identify the skills and the standards that need to be put in place. And it makes sure that, in fact, all the systems capabilities are within easy reach of those who are responsible for delivering the business services. Now, I want to say something especially about the systems of intelligence, because that is the main differentiator, and that's the whole point behind Jerry Chen's paper, is that these will provide the new defensible moats around your business and your business services. So it's in fact a very, very useful framework in a business products and services context. Now, the key challenges for developing these business and digital services, and you just need to make sure of my time, are here. I don't propose to go into those in any depth. If you'd like a copy of this presentation, and you're very welcome to it, and just let us know. But I would like to just quickly say a couple of points about some of the principles that we've learned in the work that we've done within the utilities environment. And the first one is understand how best to provide an innovation platform, especially when you're dealing with the pressures of rapid change and flexibility within the business. It's imperative that you understand the innovation management system and that you're able to evolve that on a constant basis. It needs a number of specific elements. Typical elements would be a technology scanning component, including understanding the customer needs within that context, and understanding also the business objectives and how that actually affect the capabilities of the business. One of the things that is really important is the fact that we are doing an agile development. And you'll see that there are plenty of iterations. Those are design, development, test iterations. And this little diagram on the side is an example of a basic innovation system, and you can see from the circles on there, there's constant iteration cycles at several levels within that system. And then finally, once everything is taken, is complete, the new service is complete, taking it obviously for market testing, and then ultimately implementation in a pilot project. Very quickly, beg your pardon. Taking a data-driven approach, Martin Wilcox this morning gave a very eloquent discussion behind why that is important, and I don't propose to repeat it. Don't compromise on service design quality. It's absolutely critical, that design, because that will determine what's developed and then subsequently what you're going to test against. If you get the design wrong, you've got everything wrong. But the last one is the one that I'd like to just quickly mention. Understand and manage third-party risks, particularly if you're bringing in third-party systems. Now, we all like to build on the shoulders of giants, but you really do need to look at the service contract, because thereby hangs quite a lot of business risk. If those third parties fail, however big they are, the damage that it can do to your business is extreme, especially if you have a big development cost for integrating with those third-party service providers. And it doesn't matter whether it's actually providing artificial intelligence or just simply data that you're using. It's significant. The biggest problem is that if you actually look at the consequential loss in the service contracts, it's normally predicated by the operating costs, not by the development costs that you need to put in upfront to integrate. Ladies and gentlemen, I think that's all the time that I have.